Hello my friends and welcome again to my video channel. Today in part 2 we will continue our work on the Drake TR7. At the end of part 1 we have seen that there is a problem with the, let us say, frequency generation, some instabilities. Other frequencies are stable. We have seen that depending upon the setting of this frequency selector, the VCO is locking or not. This may have many reasons. We have PLL loops in it. The PTO could be the problem, but I don't think, as we have seen. So first, when looking for a fault, we always should look into the concept to understand how the concept works. And when we know the concept and when we take our observations of the problem, then we can try to take the concept and put it onto the error or vice versa. And then it is in general obvious where the problem is. So let's start. Let's have a look at the frequency concept of the TR7. The quality of the copy isn't the best. I'm sorry, but I will explain it. That's the input, that's the antenna input, antenna relay. The first IF is 48 megahertz. So the VCOs are always above the receive frequency by 48 megahertz or more. The frequency of the VFO is 48 to 78. We have here two VCOs, not only one is shown here, there are two. And this VCO is part of the PLL loop. Here we have the PTO, the range of 5 megahertz. Here we have the reference frequency, 40 megahertz coming in. It's 45 megahertz. And the output frequency of the VCO, which goes to the first mixer, also goes to the to this translator. It's also a mixer. And to the low pass filter, and it is divided by N, and N is set by the band switching or by the digital control when we have the TR7 installed with the counter. This division by N is gives 500 kilohertz. This is also 500 kilohertz coming from the reference board, and this is a phase detector. The phase detector operates at 500 kilohertz, and when the band is changed, this factor N is changed. So we have a different frequency, and the PTO does the fine-tuning. What did we observe? We observed that some frequencies are okay in the lower bands, and in the higher bands there is trouble. So most probably we have a problem here because we have here two VCOs, not only one. So we should have a look at the VCO board, how it works. The VCO board shows us two VCOs, one for the so-called low range, other for the high range. The low range covers the receive or transmit range from 0 to 15 megahertz, and the high VCO covers the range between 15 and 30 megahertz. They are identical in the schematic. Oscillator, cap diodes, they are tuned coarse and fine. There are another diodes. And when selected low, then we have here positive power supply. When selected high, we have here the positive power supply. The PLL loop is the same for both, because we have two VCOs, but only one is operating at one time. So we can use the same PLL. We have here the 500 kilohertz input, as we have seen. This is a phase detector, MC14046 or 4046. It's a known phase detector from those days. We have here the filter and amplifier, and the error voltage gives here the fine tuning to these two cap diodes. And for bigger deviations we have here another amplifier with the diodes. This is a coarse tuning which goes to these diodes. We have here 6 diodes, and for the high range only 4 diodes, cap diodes. But the principle is the same, and the operating range is only a little bit different. But in general we have only one PLL loop. The output is switched together by these switching diodes. This diode or this diode is conductive, goes to this impedance converter, to the TR7 for frequency measurement, or to the up converter, to the first IF generation, that's the VCO, or to the translator board where the divider by N is the prescaler, and so on. Well, and what did we observe? We observed that the range low is operating. 0 to 15 megahertz, we have no problems. So this range is okay, this PLL is okay, this output is okay, and when we go to the high range, to this range, we have the problem. Setting about 15 megahertz in the band selector switch, then we cannot tune. We have the problem of instability. We can assume that the problem is in the prescaler, because when we go to the high range, the prescaler also is switched, which is not shown here, or the problem is in the oscillator. First we will do a check again for low and high, and then decide what to do. I'm in the range of 14 megahertz, 7 megahertz, 5, 3, 5, everything is okay. When I go 40 megahertz up, up, 49, okay, I can go tune above 15, but still we are in the band of 14. So we are still on the low VCO, and then I go one band up. Now it works. Okay. Sometimes we have a problem. Sometimes we have no problem. Now it works. It is sporadically a problem or not a problem. But again, we have the problem when we select more than 15 megahertz, 15 to 22 or 22 to 30. This is a range where the high VCO is switched on. Okay. Now we have the problem. Well, I think the problem is in the VCO. That's my first assumption. Maybe I'm wrong. But anyhow, if the problem is in the prescaler, it's also be under this TR7, so we have to take out the TR7 anyhow. I don't think that the problem is in the TR7. The problem is really in the VCO range, maybe in the prescaler range. So first step, I will take out the TR7. I check, of course, the supply voltages first. There's a 24 volt supplied from this board, but I think it's okay because 24 would also affect the both VCOs, and then when one VCO is working, the other not, the supply voltage should be okay. But first I will check the supply voltage at 24 volt. We have here the output of the power board. Here we have ground 0. This is 24 volt. We have 24.6 volt. This should be -5. I'm measuring -3.7, but as I know, this -5 volt is not so important. Here we have the +10 volt, the reference voltage, 10.08. And here we have the voltages for the various modes, which are aligned by the blue pots. But the power supply is okay, and now we can focus on the VCO board. But before we get in further detail, we should first check whether the supply voltages, or better said the switching voltages, this is a VCO unit, reach to the pins. We have here two inputs. One is for the low input, which supplies 10 volt in the range of 0 to 15 megahertz, and the other one is a high input, which supplies 10 volt to the high range 15 to 30 megahertz, where we have problems. So pin 517 and 518 should be checked. We have here 517. You see the voltage on the voltmeter. It is for the, which range is it? For the low range. We are in the low range. When I go to high range, it disappears, but now we have the voltage at pin 18. Low range. Now to the high range. We have here sorry, wrong one. This is high range. And in lower range we have here the voltage. So the switching voltages are present. You hear again the problem, but we have full 10 volt. So the problem is not in the switching, not in the power supply of the contacts for high and low switching, so we have to look for another problem. The TR7 board is out. Instead of the TR7, there's installed the so-called jumper board, which is necessary to transfer the data from the band setting into the synthesizer. So we have no up and down keys and no digital display. We only have the bands which are marked here and the auxiliary bands, of course, but in the moment we are on the 7 MHz band and can only align it with the mechanical VFO. These bands are all okay. And when we go to higher than 15, without calibrator, with calibrator we have the same problem as before. Okay, sometimes it works. Sometimes not. This shows us that the TR7 is not the problem. So it's getting interesting. Is it the VCO board or maybe the pre-scaler where the division by N is made, which is also controlled by this switch? For this purpose I will take out now the VCO board, use the extenders, and then we can check whether the VCO board is a bad guy. The VCO board is now on the extenders. The transfer board is also on an extender to shift everything up. This is the output of the VCO. The VCO is completely shielded. When we want to replace something, we have to remove the shielding. But first we check it. And I've seen that obviously someone was in this region. This region here looks resoldered. I think it's not original. And this is a VCO2 for the high band. And when we go to the high, we again have the problem. Suddenly it locks, unlocks. It locks again. This is VCO2, the high VCO. Very touchy. Obviously the problem is here. I will first measure the tuning voltage. Maybe this VCO is only misaligned, that the alignment is not correct, or one of the cap diodes is not working as it should. So this would be indicated by a bad tuning voltage, because the fact is when we go to the next frequency, to 28.5 MHz, we don't have this problem. It unlocks, but locks. Okay. Well, I measure first the tuning voltage. Here we have the test point for the VCO voltage. The tuning voltage I'm measuring approximately 12 volt DC. When I try to lock it, doesn't work. Okay. I'm measuring 16 volt. Okay. The locked voltage is 16 volt, and when I tune the frequency with the VFO, The voltage varies, of course, but it's always in the range of 15-16 volt. When I go to 28 megahertz, this voltage goes up to 17 volt or so. Of course, this voltage of the PLL varies when the frequency is not okay, because the PLL tries to lock it. Well, we have to check whether the problem is the VCO itself, that there's a problem in the maybe transistor, cap diodes or other component, or whether we have a problem in the PLL. So I will think about it. The shield of the VCO board is removed. 3 pins and 3 pins also here on the ground connection. A little bit difficult to unsolder it here close to the pins, but it's possible, as you see. And now we have a view onto the 2 VCOs. This is a VCO which makes the trouble. Here we have the other VCO for the low bands, that's okay, and here we have the VCO for the higher bands. This big yellow blob is a tantalum cap, 47 microfarad, to stabilize the voltage. We will measure the voltage, supply voltage of the VCO. It is 5 volt, but as I have seen, it's okay, so no problems with the supply voltage. So we can now focus on the oscillator itself. We have the problem. You can hear it. No contact problems, but when I touch it, it's okay, as we can hear. And when I touch it again, we have the problem. It's okay again. Well, what could be the reason? I don't see any bad solder connection. Yes. The 2 cap diodes maybe are the problem. Another component, okay, the tantalum cap, but when the tantalum cap is not okay, I'm not sure whether it has such a behavior when I touch it. This behavior is more or less a problem with the tuning range. This could indicate a problem with the cap diodes, or with the setting, of course, of the coil here. I removed both cap diodes, and surprise, surprise, I found these were not the original ones. The original ones should be the MV104, but I found in the BB204. It's also a double cap diode, but with yes, the capacity, maximum capacity with 30 picofarad per diode is the same, but the minimum is much smaller. So this cap diode has a bigger ratio between max and minimum capacity. The MV104 has a ratio of 3 or so between max and minimum capacity, and this one is, we could say it is steeper and generates more capacity variation. This could cause stability problems within the VCO. I ordered new ones, MV104. I have found at acceptable prices. I think 1 or 2 euros per piece. Okay, it's not the cheapest one, but I think it's acceptable as long as they are original and good. I swapped also this tantalum cap here. This was the original. The original was bigger, and the new one is smaller and has a higher voltage rating. It has 47 microfarad tantalum cap, 47 microfarad and 15 volt now. The original one had 6.3 volt. So supply voltage here is 5 volt. At a 5 volt supply rail, a 6.3 volt tantalum cap is not the best solution. I also swapped the tantalum cap for the second VCO here, this one. So both are now new, and the diodes, I have to wait for them and see whether it improves the situation, whether we have, when we replace the BB204 with the original ones, whether we have a better characteristic and maybe stability now. If not, we have to go to the FET transistors. This will be a problem. The type is completely unknown in the net. Didn't find any information about it. I only know it's a depletion type. The SPF796 Sierra Papa Foxtrot 796. If there is anyone out there in the net who knows something about this, it has a negative gate voltage related to source. Okay, it's a depletion type. That's what I know. Same we have here, minus 1.75 volt. This voltage is generated by the diode. The positive half wave is shorted to ground and the negative is stored, so we get a negative voltage here in this bias circuit here. But again, I couldn't find any characteristic or so. Maybe a modern type will be sufficient as long as it is a depletion type with negative voltage. I will see, but first I will wait now for the new diodes. The new diodes are in, new cap diodes, but the problem still persists. I can align this core when it is locked to the voltage of approximately 15 or 16 volt at the test point, which is here on this side. Sorry, this point on this side, as it's stated in the manual. But still we have the problem. Non-stable. And when I touch it, dentist effect. Okay. Well, the problem still persists. The amplitude is also a little bit low of the calibrator. Could be a problem in the amplitude of the oscillator, because in lower bands it is much higher. When I go to 14, 7 and so on, and the fall down to 21 is rather high. There is still a problem. Maybe the transistors are bad or any other components. I have to look for it, and of course I will continue. Now we are at the end of part 2. This part 2 didn't end not such as successful as I hoped. We have in the original cap diodes, didn't solve the problem, so there are still other components which may be faulty. Yes, the two transistors, the two FETs in the oscillator, but there are also other components. There are two diodes for biasing, as we have seen, or maybe we have a faulty resistor or simply a capacitor which lost capacity or so. We have to look at it in the third part, but for now I will close it. Think about it. Maybe I have an idea overnight or so. Stay healthy, stay tuned. See you on this channel.